Today I'm going to go over 2 fraction word problems. This is the first one. 5 people are going to Deborah's house for an Easter egg hunt. If she wants each person to go home with 2/3 of a carton of eggs, and you can only buy whole cartons at the store, how many cartons should she have her mom buy? Note, Deborah wants to hunt for eggs too. All right, so the fraction makes this a little intimidating. So what I like to do is I just draw a picture first because that just calms me down a little. So I drew a picture, and these are the people that are going on the Easter egg hunt. Deborah, who likes to go by Debbie, Kiana, Macy, Jasmine, Sarah, and Maya. So it says she wants each person to go home with 2/3 of a carton of eggs. So all I'm going to do is give each one 2/3. So I'm going to put 2/3 here, 2/3 here, 2/3 here, 2/3 here, 2/3 here, and 2/3 here. Now everyone has 2/3 of a carton of eggs. But I need to find out the total number of cartons that I need to buy. And remember, a carton of eggs looks like this. Okay, so how many of these can I buy? I can't just buy a partial one. I have to buy a whole one. All right, so this looks like repeated addition to me, so I'm just going to do it with repeated addition because that's a good method. So I have 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3. Now I'm going to use my song because whenever I see a fraction, I just think of that song, adding and subtracting. That's what I'm doing. It's plain to see. You match the bottoms perfectly. So it looks like all the denominators are the same. So I'm going to match the bottoms with a 3. And then it's adding, so I just add the tops. So I'm going to do my skip counting. 2, 4, 6, 8, 10, 12. Now this is an improper fraction, and I know the improper fraction will have hidden holes, and those holes will be whole cartons of eggs. So I'm going to write 12/3, and I know whenever the numerator is bigger than the denominator, I have hidden holes because it's improper. So I'm going to take out a hole. I know when the bottom and the top number are the same, I have one hole. So that gives me, get a red, this is one hole. So I took out this hidden hole from 12/3, and I can take out another hole because that would be 3/6. Okay, but I have 12/3, so I can keep going. So I'm going to keep going until I have 12/3. So I'm going to take out another hidden hole. Boy, there are a lot of hidden holes in this. Okay. Got this one. And I have 3, 6, 9/3. Still not 12/3. I can take out another third. And if not, I would just erase this number. But I think that's going to add up to 12/3. Let's see. Adding and subtracting is plain to see. You match the bottoms perfectly, then you add the tops. 3, 6, 9, 12. There, I've got it. So it looks like she would need to buy 4 cartons of eggs. So I'm going to put this pin, which is equal to 4 cartons of eggs. So that's how many her mom would have to buy at the store. Now, you could have done this faster. You could have realized, hey, this is repeated addition. I know repeated addition is multiplication. So there's 1, 2, 3, 4, 5, 6. 6 groups. And we know that this means of, right? So it's 6 groups of 2/3. That's a fraction. So I sing my fraction song. Adding and subtracting is plain to see. You match the bottoms perfectly. Nope. Oh, multiplying fractions is no big problem. It's the top times the top. But wait, this isn't a fraction. So I have to make it a fraction, and then I can use the multiplication one. Multiplying fraction is no big problem. It's the top times the top, which will give me 12. and the bottom times the bottom. 1 times 3 would give me 3. And look, I've got the same improper fractions, so the same hidden holes would be in it. So this would be my answer. So you could do it with repeated addition, or you could do it with multiplying fractions. That is the first problem. Okay, the second problem. JoJo has a running team made up of herself, Faith, Josh, and Parker. If each runner runs 3/5 of a mile, how many miles does the team run altogether? Again, I'm a little bit freaked out by that fraction, so I just draw my pictures and I have them all. I've got JoJo, Faith, Josh, and Parker. And I know each one of them is going to run a certain distance. So I look and I'm like, oh, it's 3/5. Okay, so I'm going to write JoJo 3/5 in her head. Sorry about that. And then Faith ran 3/5. I'm going to double check that too. 3/5. And Josh ran 3/5. And Parker ran 3/5. Now, what the problem wanted us to do is they said, how many miles does the team run all together? So we want to know how many miles they ran all together. So it looks like we have 4 people. Wait, this looks like repeated addition, so I'm just going to add again. So I have 3/5 plus 3/5 plus 3/5 plus 3/5. Now I know adding and subtracting is plain to see. You match the bottoms perfectly. And then I add the tops. 3, 6, 9, 12. Now, you could leave the answer like this. It would be 12/5 miles, but it is improper. So you might want to find the hidden holes. Because remember, when the top number is bigger than the bottom, there's hidden holes there. So I'm just going to try to pull out the hidden holes. I know whenever the numerator and the denominator are the same, that equals 1 hole. So here's 1 hole. So I've got 1 hole. And I think I can pull out another hole because that's 5/5. I don't have 12/5 yet, so I'll try another 5/5. And then I notice I have 5/10, still not 12/5. So all I have to do is add a 2/5. So now I'm going to check that. Adding and subtracting is plain to see. You match the bottoms perfectly. That's a 5. And then if I add the tops, 5, 10, 11, 12. So this is equal to 12/5. And now I know that problem there's 2 holes and 2/5. So I have a mixed number here. And my answer would be 2 2/5 miles. So you could write the answer like this, or you could write it like this. So you could write it as an improper fraction or a mixed number. It didn't say which one you had to do, so you could do either one. Or I could solve it a little faster. I could have done it with multiplication, knowing that there's 1, 2, 3, 4 people, or 4 groups of. Remember, the multiplication sign means of. 4 groups of 3/5. So I'm going to write 3/5. And then I'm going to do my song. But first, I know this is going to be the multiplication song, but if I do the multiplication song with fractions, both numbers have to be fractions. So I'm going to make 4 holes into a fraction by just making the denominator 1. Now, adding and subtracting is plain to see. You match the bottoms perfectly. Multiplying fractions is no big problem. It's the top times the top, which would be 12. And the bottom times the bottom, which would be 5. And again, you can see I would get the same answer. So you could either multiply or you could use repeated addition. But no matter what, you are going to get an improper fraction and you're going to have to find the hidden holes. Hope that helps. Thanks. Bye.